So let's start with the different types of shrinkage. There are four types of shrinkage that are seen in the concrete, that is plastic shrinkage, drying shrinkage, autogeneous shrinkage, and carbonation shrinkage. Let us go into each one of these shrinkages. So first one is plastic shrinkage. Shrinkage that is seen when concrete is still in plastic state is called as plastic shrinkage. So what do you mean by the concrete still in plastic stage? So this is the stage when the concrete did not completely set, did not completely harden. Okay, that is the stage the concrete is still in plastic stage. So during that stage of plasticity of concrete, a shrinkage is seen in the concrete, and that is what we call plastic shrinkage. So this plastic shrinkage is seen after concrete is placed. So concrete ni eppudu place chestam? We place the concrete when it is still plastic. Still it has the property of flowing, right? So that is where you see. So what are the reasons behind this plastic shrinkage? The first thing is the loss of water by evaporation from the surface of concrete. So the concrete surface, when you are mixing and placing the concrete, for example, we are constructing a slab. So you have all the formwork that is placed, wooden planks and everything, supports and everything. And when you are placing the concrete over a large area, spread in the large area, the complete top surface is being exposed to the outer environment, outer temperature. So water has the chance of getting evaporated. It is getting evaporated from the surface of the concrete. And the second thing is absorption of water by the aggregate or subgrade. Aggregate which you have used inside the concrete to make the concrete, those aggregates can take the water, can absorb the water. So what does this lead to? This leads to shrinkage, because after absorbing of water by the aggregates are not going to bulge out like balloon. They are going to be like that only, but the pores inside that aggregate are going to fill with water. So by absorption of water by the aggregates is going to lead to the volume shrinkage of the concrete. This is called as plastic shrinkage or subgrade. So if you place this concrete on a surface, something like concrete pavements, the below surface absorbs the water. Okay. So in the same way, instead of aggregate, subgrade is actually absorbing the water. Okay. So whatever it is, these two will lead to the plastic shrinkage. So the reduction in volume or shrinkage strain is equal to 3 times the linear contraction in this particular case. And the units are mm per mm, usually expressed in terms of 10 to the power of minus 6, because this strain, decrease volumetric strain is going to be very small. So you have to, it is going to be in decimal all the time. So it is going to be expressed in terms of 10 to the power of minus 6. So what are the favorable conditions for the plastic shrinkage? Okay, what is actually encouraging the plastic shrinkage? So if you understand this, what you can do is you can actually decrease the shrinkage when it is in the plastic state. ఓకే, సో ఈ ప్లాస్టిక్ షింకేజ్ ఏదైతే ఉందో దీనికి కారణం అవుతున్న ఫేవరబుల్ సిచ్యువేషన్స్ నేను అర్థం చేసుకోగలిగితే ఐ కెన్ యాక్చువల్లీ డిక్రీజ్ దిస్ plastic shrinkage. The first one is in concrete floors and pavements, surface area exposed to drying, isn't it right? So as I told you, even the concrete roads or a slab, the concrete is going to spread over a long stretch of area, and it is going to expose it to hot sun and drying wind. Wind is going to flow over the concrete, it is going to take away the water on the surface. So it dries faster on the top side, and therefore it leads to plastic shrinkage. And sometimes poorly made concrete with high water by cement ratio undergoes bleeding. The water accumulated out, okay, will be evaporated, leading to shrinkage. Okay, this is not just with exposing, if you add more amount of water is going to bleed out onto the surface. పైన సర్ఫేస్ మీద తేలిపోతూ ఉంటుంది. అంటే you people know this, right? Crow and water bottle story. Pot story. So in the pot there is a little amount of water. So the crow has come with some stones and put it in the pot. So the stones go down and the water comes up. It drinks and flies away. So in the same way, the water which is present in the concrete is going to come up. Okay, is getting exposed. It is going to be bled out. So that water will evaporate. So this is the fastest way of evaporating or loss of water in the concrete. So this leads to the plastic shrinkage. And plastic shrinkage is sometimes plastic concrete is sometimes subjected to unintended vibrations or yielding of formwork, which again causes plastic shrinkage cracks, as the concrete at this stage has not developed enough strength. See, when the concrete is getting hardened, what happens is it is gaining strength. Okay, but it is still weak. It did not achieve its sufficient amount of strength. So before attaining this enough strength by the concrete, if you disturb the concrete of the by disturbing the supports, say for example in the slab you are going to put some supports down, right? The steel members or the wood members, right? Karal Bertama. So they are the support. So if any unintended vibrations or anything yielding or breaking of those supports happen, it leads to the cracks, unnecessary stresses and cracks in the concrete. But cement content also influences the shrinkage when the concrete is plastic. A rich concrete or a concrete with more cement undergoes greater plastic shrinkage. Therefore, we can say that high water by cement ratio, badly proportioned concrete, that is, if you add more cement or more water, rapid drying, ante ila surface ki expose ayi cement or concrete surface being exposed to the atmosphere and getting dried very quickly, and bleeding, unintended vibration, etc., are some of the reasons for plastic shrinkage. So you can decrease the shrinkage due to plastic shrinkage, overall shrinkage, by controlling the plastic shrinkage, right? You know what are the factors that are influencing this plastic shrinkage now, so you can do that. Okay, so this graph here helps us to understand this simple thing here, this loss of water, how the loss of water is going to actually lead to the decrease in the shrinkage strength. Okay, so see here, this is shrinkage strength, and this is the percentage amount of water. So the decrease water loss, this is water loss, therefore it is represented with a negative. So when the water is going to be decreased by evaporation, what happens to the shrinkage? It is going to increase. See, this is this 0. It is going to increase. Okay, so this is the water by cement ratio of 0.7. So based on the water by cement ratio that you have adopted at the beginning, the shrinkage strain is going to be depending on it. Okay. Now, so how are we going to reduce the plastic shrinkage? We have seen earlier what are the factors influencing the plastic shrinkage. So let us see this. So preventing the rapid loss of water from surface can be done by covering the surface with polythene sheets immediately after finishing operation. So finishing అంటే ఏంటంటే ఇప్పుడు కాంక్రీట్ స్లాబ్ నేను వేసిన తర్వాత, సో వాట్ హ్యాపెన్స్ ఈస్ మాసన్ ఏం చేస్తాడంటే వర్కర్ వచ్చి హీ విల్ స్మూత్ అండ్ ది అవుటర్ సర్ఫేస్, రైట్? ఇప్పుడు మీ వాల్స్ చూసారనుకోండి, వాల్స్ ప్లాస్టరింగ్ చేస్తాం, యూ డూ ప్లాస్టరింగ్, యూ మేక్ ది సర్ఫేస్ ఆఫ్ ది వాల్ స్మూత్, you apply some cement mortar and you will smoothen the surface. So that is finishing. So when this finishing is done, you immediately cover the surface with the polythene sheets. So because of this, water is not going to be lost due to evaporation. Water is going to be remained there itself. And molecular coating by fog spray. We have certain sprays just like paint. They are sprayed on the surface of the concrete, and also by working at night. So when you work with concrete at night, the temperatures are not going to be high, right? There is no chance for evaporation because there is no sun, there is no heat, there is no evaporation due to sun. Okay. And revibrate the concrete in a controlled manner. So if you see that concrete is bleeding out due to excess amount of water, what you can do is you can revibrate so that water which has been bled out, came out, goes inside it again. And use aluminium powder, something like your powder, okay? Something like, see, when you apply this powder talc onto your skin, what you are doing is you are actually covering the sweat pores, so that's the sweat is not going to come out. That is what you do. In the same way, when you apply this aluminium powder on the concrete surface, the water which is trying to come out of the concrete through the pores is not going to come out, because on the top surface this aluminium powder is going to form a layer. And you can use expansive cement. Expansive cement is the cement that expands on setting. So because of shrinkage, loss of water, cement tries to contract, shrink, decrease in its volume. Whereas this, when you use this expansive cement, what happens is when the cement is undergoing shrinkage, cement also tries to expand because of its property. Okay, because of loss of water, shrinkage is going to happen, but expansion is going to happen because you have used an expansive cement. We are going to see in detail about this expansive cement in our unit 6 in different types of concretes. Okay, so this is how you are going to find cracks. This is a pavement and these are shrinkage cracks. So how exactly these cracks are being developed in the concrete due to plastic shrinkage? So we have seen earlier that while the cement paste is still plastic, it undergoes a volumetric contraction due to loss of water due to evaporation and suction by dry concrete below. Because of the absorption of the water by aggregate or by evaporation, volume contraction is going to be seen. That is plastic shrinkage, right? But how does this actually lead to the cracks in the concrete? Okay, so the contraction, when the concrete tries to contract, mudscovaldan try చేసినప్పుడు coming closer, tensile stresses are going to develop on the top surface. Okay, let me show you this figure here. See here, this concrete pavement has certain thickness, something like 15 centimeter. So the top surface is being dried. Okay, so it is trying to shrink, but whereas the concrete layers below this top layer still contain water and they are not undergoing shrinkage. So what happens? The tensile stresses are developed in the top layer, and what happens is because of the tensile stresses, cracks are induced or produced or seen or developed in the concrete. So since concrete is very weak in this stage, even small tensile stresses will lead to the cracks on the surface that are visible as in the previous image. So this is the reason we are able to see cracks due to shrinkage on the concrete floor or the walls and everything. Okay, in the next video we will continue this and we will discuss about drying shrinkage. Thank you.